Welcome back to R Programming 101. In our previous video, we learned objects, and now we are ready to go into the real world, take some data, and pass it to these objects and do some analysis with them. But before we can do that, we need to order our data in some way. We need data structures. So today we're going to talk about one of the basic forms of ordering data in R. We'll talk about vectors. So a vector is basically a way to order data in R, right? It's a basic data structure in R. And with vectors, you can only have one form of data type. So a vector can either be a numeric vector, an integer vector, a character or string vector, or a logical or boolean vector. It cannot be it cannot be two data types in one vector, right? So let's go ahead and create some vectors for ourselves, right? But before we do that, let's talk about the combine function. You remember in our previous video, we spoke about functions. We said functions were some instructions you put in a name that you would call a function, and that anything you pass to that name, it gives you some information that pertains to the instructions that are embedded in the function. So we use a function called class, and then we put some information in there, and then R told us the data types of the data we put in that function. So to create a vector, we need another function, and this function is called the combine function, right? Let's illustrate it here. So the combine function is denoted by a C, and as usual, every function comes with a parenthesis because that is where we're going to put the information that we want the function to operate on. So anytime you want to create a vector, we're going to use this C, which is a combine function, to combine some data from the real world into an object, right? And that can be a numeric that can be in a numeric data type, can be a string or character data type, it can be a logical, or it can be an integer. So let's go ahead and use this new function that we've learned to create vectors. I'll start by creating, I want to create, I want to create a character or string vector. Assuming in the real world, we have some information about the political parties in the United States. We have the Democrats, the Republican, and then all the other parties. We're gonna group them into others, right? So let's go ahead and then create a string vector. Yes, now we have here a string vector or a character vector. We created an object called party affiliation, which is the political party that someone in the US belongs to. And then we use our combine function to put together the names of these political parties that some people that we asked said they belonged to. Remember, because it's a string or a character, we write it in inverted commas so that R knows that, right? Now let's create another vector called policy support. Now, assuming here in the United States there was a policy that some people supported and other people did not support, and then we ask people, do you support the policy or not, true or false, then we can create a logical vector that has true or false values. Now, these are people saying, we support the policy. Well, yeah, no, maybe we don't support the policy. We are also interested in another policy here in the US that that was passed, let's say sometime last year. We want to find out whether the policy was effective or not. So we went to the public, and then we did a survey, and then people said, well, yeah, we support the policy on a scale of 1 to 10. And we got this particular information where we created a numeric vector, and we created an object called policy effectiveness, and these are the scores that people gave the policy. So we used our combine function to put these scores together, and then we named it under a policy effectiveness object. Now remember, a numeric vector can have infinite numbers, so it can have decimals, it can also have integers. Now we have one data type left, and then we can also create a vector with it. So we can create an integer vector. Now we are interested in the number of terms that US presidents, some past US presidents have served. So we can create an integer vector, that says, okay, this US president served, let's say 2 terms. This one served 3 terms. This one served one. This one served four. I know this is not real, but assuming it was, then we could create an integer vector and then have this information presented to R in this way. So we have 4 data types. We spoke about the string, the logical, the numeric, and the integer vector. And we have different types of data that we pass to these objects based on whether we want to create an integer vector or numeric vector or so on and so forth. So now, congratulations, you know how to create vectors in R. It will be fun to be able to do some analysis with it, right? So this is where you become a data analyst, right? So right now you just got a new job. You're a data analyst for a political related organization, and then they want to organize some pooling data, right? For a moment, let's assume that we conducted a survey, and in the survey we asked people to choose between whether they were part of the Republican Party, they were part of the Democrat, or they were part of any other party. And we said, if you're part of the Republican Party, choose one. If you're a Democrat, choose two. And then if you were part of any other party, choose three. Now, two doesn't mean that Democrats are better than Republicans. These are just number tags that we've assigned to these political parties here in the US. Later on, we're going to talk about types of variables where we talk about nominal, ordinal, and other types of variables. But for now, just understand that 2 is not greater than 1 and 3 is not greater than 2 and 1. So now let's go ahead and organize the survey that we just conducted into an object or into some vector, so we can have this particular information. So we went to the US public and it said, okay, what political party are you affiliated to? Some said they were part of the Democrats and Republican, and others choose others. So we put it together using a combined function, and we assign it to political political affiliation. We want to find out if this particular object really exists, right? Now let's run everything that we've done in R. Now there's an object called political affiliation, or a variable called political affiliation, and it has this data in it. Okay, so now our survey data is coded. Let's do some analysis with our survey data, right? You remember we are the data analyst of some company, and then they want us to analyze this political party related data here in the US. So I think most data analysts will be interested in the number of respondents, or the number of entries in their data sets, right? So I'm going to introduce you to a new function called length. Now, what this function does is that it gives you the count of entries in your data, right? So let's go ahead and use this function called length to find out how many people filled our survey, right? So we're going to create a new object called total respondents, that is the total number of people that filled our survey, and pass political affiliation to this function called length. Okay, now let's run it and see what we have. All right, so we can see that, okay, 10 people filled our survey. Okay, that's not bad, assuming there are only 20 people in the US. We have 10 people, that is not bad. We'd also be interested in the number of people that are affiliated to a particular party in the United States, right? So how many people are affiliated to the Democrats, the Republicans, or others? Okay, so now let's create a new object called count Republican. And in this object called count Republican, we want to find out the sum of people affiliated to a particular party or not. And then we are interested in, so first of all, we want to find out the number of people that are Republicans. So we're going to pass the sum function political affiliation. Okay, great. Now we passed political affiliation to the sum function and assign it to an object called count Republican, because we want to count the number of Republicans who filled our survey. Now, remember that Republicans have been labeled with a tag called 1. So we want to say that for everyone in our survey who chose 1, say that the person is a Republican and give me the sum of Republicans in our data set. So in R, if you want to tell R that give me a particular entry that matches this figure or this name, you should use the double equal sign, right? So the double equal sign tells R that we want exactly the match of one in our data, right? And we are not saying that political affiliation is equal to one. We are saying that go into the data and then find out all identical values of one. So let's run our data. Let's run this and see the number of Republicans that we have in our party. Later on, we're going to call the count Republican function and see the result. But let's do the same for the Democrats and others. Okay, so now we've counted the number of Democrats and the number of others. Let's call the objects we just created. Let's call the objects we just created and see what we're gonna get. Okay, nice. We have 4 Republicans, 4 Democrats, and 2 others. You should put R in your CV right away because you are doing analysis. You're doing real analysis right now. Now let's do one more thing before we go. Right? Let's do something to impress our boss. We want to find out the percentages of respondents for each particular political affiliation. Remember, sometimes percentages takes more than just numbers. We want to say 40% Republicans, 40% Democrats, right? Instead of just saying 4-4-2. Okay, because in the real world, when the data is so huge, you want to shrink everything to percentages. So let's go ahead and create percentages out of the numbers that we have right now. Now with percentages, we are not going to do anything really special. We're not going to bring any function. We're just going to do basic mathematics. Now look at this percentage calculation for Republican, and I'm going to explain it. So we have a fraction here where count Republican is the number of Republicans that we have, which is 4, right? Out of the total number of people that filled our survey, that is 10. So R is going to do 4 divided by 10 times 100, because we want to change everything that we have. We want to change 4 divided by 10 to a percentage, so we're going to multiply by 100. Very basic mathematics. And we can do the same for the other 2 parties. So the percentage Democrats, the percentage others, and then we assign everything to a new object that we are creating for percentages, right? So we just did that, and let's go ahead and run it. All right, we just run it. Let's call these objects. So we have 40% Republicans, 40% Democrats, 20% others. This is good news. Now you just learned vectors, and you've been able to use vectors to do basic political analysis. Assuming the United States was this small, we can just go ahead, present this data to the political parties, and help the political parties do their campaigns in one way or the other. Maybe if the Republicans need more than 50% to win, then they can step up their game. So can the Democrats and the other political parties. And we can do the same for big data as well. It is nice that you know how to do this with small data. As we keep on going forward, you'll be able to do amazing stuff with big data. We have more to learn about vectors. In the next video, we'll talk a little bit more about other things that we can use vectors for, other ways that we can manipulate vectors or manipulate such basic data in R. If this video proved helpful, please like and subscribe to my YouTube channel to get an alert anytime I upload videos like this. See you next time.